Defining Activation Energy by me, Walt McGrory. What does it mean? Activation energy is defined as the minimum amount of energy needed to start a reaction. This energy is what is needed to disrupt and break existing bonds so that new ones can form. A real-world scenario to understand this concept is someone pushing a rock up a hill in order to roll it down the other side. The person's starting point to the apex of the hill is the activation energy. If the person doesn't push the rock far enough, then it will roll back down without making it to the other side. If the person is able to push the rock over the hill, then they provided enough activation energy for the reaction to occur. In this graph, E of A is equal to the activation energy. Delta H is the change in energy during the reaction. The reactants are the molecules before a chemical reaction, while the products are molecules after the reaction. A way to lower the activation energy is by using a catalyst. Also, in order to react, molecules must not only collide with enough energy, but also proper orientation. Heat raises the energy level of molecules, giving them a higher chance to react. Lighting a match. This is an example of activation energy. The head of the match is made up of potassium chlorate, and the red, rough surface called the striking surface contains red phosphorus. When the match is struck against the rough surface, the friction between the two creates enough heat to start the reaction between the chlorate and the phosphorus. In this situation, the heat from the friction of striking the match is what gives the reaction enough activation energy. Here's a video of me lighting a match to demonstrate activation energy. As you can see, the friction from striking the match causes the potassium chlorate and phosphorus to react. Here are some practice problems to review the concepts you just learned. Question 1. Which graph has a higher activation energy? The answer is graph B because it has a higher activation energy barrier that requires more energy in order for a reaction to occur. Question 2. What happens to the activation energy when a catalyst is added? When a catalyst is added, the activation energy barrier is lower, making it easier for a reaction to occur. How do you calculate the activation energy? The amount of energy at the height of the graph subtracted by the energy at the starting point of the reactions is how you calculate activation energy. Thanks for watching this presentation.